Hello dear students, let us look at this next topic, histogram. What is histogram? We know that when we talk about the representation of data, it could be of two types like tabular representation and graphical representation. Graphical representation is simply the pictorial representation of data and it can be done in various ways. One of those ways is histogram. How does a histogram look like? Is it different from bar graphs or frequency polygon? Is it altogether much different from the tabular representation? We will understand all of it. Let us just have a look at this example. If I look at this image, this shows that some data is presented on a graph page with two mutually perpendicular lines. One is horizontal and the other is vertical. These represent some heads and some numbers, isn't it? Also, if I look at it on the graph page, there are some rectangular bars being made, right? If I just darken them, this is how it looks like. Then this is another, and then this one is another, isn't it? So isn't it quite similar to what we have seen in the case of bar graph? And if it is just similar to it, what is the change? The one change which I am able to signify over here is that the distance between two consecutive bars are, there is no gap actually between any two consecutive bars. I see the bars to be, close to each other, they are joined with each other. So that is the major and basic difference between a bar graph and a histogram. Histogram is also a way of representation of data, but it is similar to bar graph, but the change is that it doesn't have any gap between two consecutive bars. That tells us about very important thing, grouped data. When we talk about grouped data, why there is a need of grouped data? When we are writing some data, sometimes we have a very large number of data. In that case, we not need to write all the data individually. We group them together and then we write it in such a way that its representation becomes easier. In a group data, we get class intervals. What do we get? We have class intervals over there. So class intervals are generally continuous. So when we have continuous class intervals, so for continuous class intervals, we use histograms. This is the case when histogram comes into picture. When we have grouped data, we have continuous class intervals, we are going to use histograms, which will depict the data, it will represent the data graphically. Let us understand it properly and write some points about it. Let us just move it aside. So guys, what is a histogram? Let us write it. Histogram is a way of representation of data graphically similar to the bar graph. Right? It is similar to the bar graph. What is the change? Histogram is used in case of continuous class intervals, right? Continuous class intervals, right? So histogram is used in case of continuous class intervals. There is usually no gap between two consecutive bars, right? This is what the major difference is between the bar graph and the histogram. Histogram is used in case of continuous class intervals, and there is usually no gap between two consecutive bars in histogram. Now also, when we talk about histogram and class intervals have class size. Like if I group some numbers, I could group them in groups like 10 to 20, 20 to 30, 30 to 40. What are these? These are the groups, isn't it? We have grouped these numbers together so that the any value lying between 10 to 20 will be written in that class, between 20 to 30 will be written in that class, and so on. So if you look at it, what is the class interval? The class interval is 10 to 20. Here 10 being the lower, it is written as lower limit, and in that class interval 20 is the upper limit. So each class interval has lower limits and upper limits. So the smaller number of this class interval is called lower limit, and the higher number of that class interval is called upper limit. Also the class mark, this is what this is all about, the class interval, and this is going to be class size. So what is class size? Class size is the difference between the upper limit and the lower limit. So for this it is going to be 20 minus 10, that is 10. For the next one, 20 to 30, it becomes 30 minus 20, that is 10. Then it is next 40 minus 30, that is 10. So what I look over here, that the class size in each class interval which is written over here is just the same, it is 10. So if the class size is same or equal throughout the class interval, then the histogram being made will have same width. You know, the width of the rectangular bar in the histogram depends upon the class size. It is not going to be kept same always. It depends upon the class size of the class interval. So if the class size is same throughout, its width is going to be equal. If the class size is different, like now if I write after 30 to 40, if I take 40 to 60, what is the class size over here? We see that it is, since 40 to 60, the difference of upper limit and lower limit gives us 20. Next, if I take it as 60 to 100, so the difference is going to give us 40. So now the class sizes are not same, they are different. So the width of that histogram's rectangular bar will also be different. Like for these three, it will be 1 centimeter each. If we take 10 as 1 centimeter, for this it would be 2 centimeter wide. For the next one, it would be 4 centimeter wide. And it totally depends upon the class size of the class interval used over there. That means histogram is also of two types. Let us write that. Let us just first erase this part. So a histogram is of two types. Histogram is of two types. First, with equal width, and second with varying width. Okay, first histogram is of the equal width, which will have the same class size throughout, and the varying width will have different class sizes, right? In case of equal width, what do we have? Same class size, and here we have varying class size. Is it clear? So if I look at it, there is one very important thing. Whenever you have varying width, you need to adjust the frequency. We are going to definitely do some examples for that. But in place of varying width, we adjust the frequency. Okay, where in case of varying width, we need to adjust the frequency. The method of doing that will be explained when we do an example, but this is what a histogram looks like. Also, there is one more important thing. If the class interval does not start from 0, we show that gap by marking a kink. What do we mark? We mark a kink that looks like this. Okay, this is very important. This kink is used to mark the gap or the the numbers which are not there in the class interval. Like if class interval starts directly from 40, if it goes from 40 to 50, then 50 to 60, 60 to 70 and so on. So we do not have any frequency between 0 to 40. So rather than writing 0, 10, 20, 30, 40, we will simply show it by this line which looks like the pulse rate like this. This will represent the gap between the first class interval and the 0. I hope you are clear with this. Let me just draw it again. I'll explain it in a better way when we do a question. So this is what is all about the histogram. It is similar to the bar graph, but the change is that we use it for continuous class intervals. We have the width of the histogram depends upon the class size, and the height of that histogram rectangular bar depends upon the frequency itself. So this is what the histogram looks like. I note it down for your reference.